Fisheries are the primary source of livelihood for several communities. India is the world's second largest fish producer with exports worth more than rupees 47,000 crore. Fisheries are the country's single largest agriculture export, with a growth rate of 6 to 10% in the past 5 years. Aquaculture is purposeful breeding, raising, and harvesting fish and aquatic plants. Basically, it is the farming in water. Currently, most of the aquaculture systems are biofloc systems or pond farming setups. They face major challenges in the form of incorrect filtration systems, leading to high mortality rate. To tackle this problem, we, the students of PVG's College of Engineering and Technology, Pune, have built a recirculating aquaculture system prototype. The 3D Experience platform has provided us with all the tools that we needed to come up with the design as well as complete the analysis of the system. Some of the tools that we have used are 3D Dashboard, 3D Sketch, Innovia Project Planning, X-Design, X-Shape, Simulia. We also have used 3D printer in our Product Innovation Lab, which is sponsored by La Foundation Dassault Systems for manufacturing of some customized parts in this project. Now, let's move on to the actual prototype.
Hello everyone, I am Surut Parag Zawekar from Final Year Mechanical Engineering Department of PVG's College of Engineering and Technology. I welcome you to the Recirculating Aquaculture System. This project was designed and developed in our Product Innovation Lab of PVG's College of Engineering and Technology, and the lab is sponsored by La Foundation Dassault Systems. The entire system is visible in front of you. First we have the fish tank over here, in which we have 150 fish present currently. Then the water is pumped to the mechanical filtration unit, and it indirectly flows through the ultraviolet filtration unit after passing it from the biological filtration device, and the water is then resupplied to the fish tank to maintain the flow. Now I would like to hand over to Kshitij to explain the fish feed system and the fish tank in detail. Thank you.
Hello everyone, and next we have our fish tank and the feed delivery system. So as you see, it is a 1500 liters water tank which we have converted into a make-use fish tank for the 150 tilapia fish that are stocked inside. The fish were stocked on 25th April and they are alive and well for almost a month and a half now. The fish are gift, that is genetically modified tilapia, and for them we need high protein feed. For that we have 3 mm fish feed of Grofin company, which has 28% protein inside. So this helps us achieve higher growth rates and also gives them all the nutrition that they need. Next we have built a automatic feed delivery mechanism so that manual inputs are reduced. We can top up the feed in the funnel above, and every day at our specified time it will automatically distribute the feed to the fish. There is no need of manual human input. In addition to this, all the parts of the feed delivery system have been 3D printed in-house at our Product Innovation Lab sponsored by La Foundation Dassault Systems. Also, the inserts for the UV enclosure have also been 3D printed in-house. As you can see, for the water to stay live and for the dissolved oxygen DO levels to be maintained, we have added 3 air pumps inside, while the tangential flow also acts as the 4th air pump. The flow ensures that all the excreta and the waste that is generated inside the tank is collected at the center of the tank, and at that position we have placed our submersible water pump. It can pump up to 1000 liters per hour at a height which we need, and that us complete our entire cycle in 1 hour. Okay, thank you. I would like to hand over to Atharva Sinnarkar, who will explain you about the mechanical filter.
Hello everyone, I'm Atharva Sinnarkar. I'll take you through mechanical filter and biological filter. So here we have a mechanical filter at the top. We have used 800 mesh above, then 200 mesh, and then aquarium sponges inside. The water first go through the all the filters and then come to the biological filter. In biological filter we have used 17 liter biomedia, which is used to convert ammonia into nitrite and then into nitrate. This is possible because of the bacteria called Nitrobacter and Nitrosomonas. So further part will be explained by Atharva Potnis.
Hello everyone, my name is Atharva Potnis. So I'll explain you about the biological filter, UV filter, and some our electronics part, which drives the feed delivery system unit. So basically, in this biological filter, we have the wave maker of capacity 1500 LPH. So what it makes sure is it just transfers, or it just wave out the water through our biomedia. So, and the main intention of biomedia is to increase surface area to just rapid out the chemical process which happens there. So this is like a catalyst, which is wave maker. So then after the water is transferred to the UV filter, so this is a 4 watt tube. So after so many iterations, we have found out a golden mid between, because there are good as well as bad bacteria. So it is necessary to kill only bad bacteria. Otherwise, the whole intention of biological filter will just destroy it. So after so much of iterations, we have found out this. So what this UV filter does is it kills almost all the bad bacteria, and it transfers to our main tank, which completes the loop as a whole. So and while transferring it to the main tank, it transfers it tangentially. So this tangentially transferring just make it as a swirl filter, and what it does is, now as you can see, our pump is at perfect center. So it just pushes all the poop and the waste to the center bottom of our main tank. Now coming to the electronics part, so we have used Arduino, which controls the feed delivery mechanism, and also the stepper motor, which is attached to the rotor of the feed delivery system. And also we have used relay, because when the feed delivery is happening, it is necessary to off the pump, because it just gives some relaxation to the fish, and so that fish can eat the food so that they can relax over there. Our next part will be explained by Atharva Sambus. Thank you.
Okay, hello everyone, my name is Atharva Sambus, and now we will move on to the future scope of this entire prototype. One of the future scope can be modifying the design of the mechanical filter, which will result in better filtration of the system, and also its maintenance will be very easy. Second future scope can be to improve the automation by using appropriate sensors, which will also result into better efficiency. Now we will move on towards the end of this video by taking the concluding part. I would now like to extend my wishes and my gratitude to La Fondacia and Dassault Systems for giving us this extremely great opportunity, so that we could work on various 3D experience softwares like 3D experience softwares, Simulia, Part Design Essentials, etc. By having a hands-on experience of this software, which have definitely helped us be industry ready. I would also like to extend my gratitude to our department, the head of our department, Dr. M.M. Bhumkar sir, and our project guide Professor V.S. Savant sir, for their valuable guidance, which helped us achieve our purpose. Thank you.